Problems for tonight can be a little bit tricky for kids, so I implore you, make sure you are thinking. Don't just memorize formulas and try to plug things in. As I tried to go over yesterday, but looking back, I wish I had made it even clearer, we have fraction, decimals, and percents that are equal. You can see that 2/5 is equal to 4/10. Hear that decimal? 4/10, which is equal to 4/100. Hear that? 40/100. Hear that? 40%. And that all of these are part-to-whole ratios. So it serves us well. That's the reason why we can use percent proportions. The simplest type of percent proportion that you've learned that has to do with percent increase goes back to 6th grade, where you learned that the change over the original, and I know I just said you're not going to memorize formulas, but I do want you to understand that this is a proportion, is equal to the percent change out of 100. And when we think of these as part-to-whole ratios, remember, the original is always the whole, so it always goes here. And it always relates to the per 100, which is on the bottom of the other part of the other ratio in this. So the simplest problems would be ones where you say there is, I don't know, a record. Something is the original price. If the original price is $12 and that's maybe somebody marks it up and the new is $15. What is the percent change? So what we don't know is the percent change, x out of 100. We know the original is always 12. Now, if I want to talk about the change, if I want this to be the percent change, then over here, this number must represent change. So if I'm making a proportion where percent change is the top of the percent, then the change itself has to be here. From the original to the new, it goes up $3. So when I do that, if I finish this particular problem, you can really kind of see, as I always say, if you can simplify up front, clearly 3/12 is 1/4, and that means that x is 25%. Based on the idea that the change over original is equal to the percent change over the original. I could have taken the same idea and said, if something started out at $12 and went up to $15, what is the percent change? I could use that same question. I could say, well, I know the original always has to be the bottom, so that's going to be 12. If I put 15 on top and 100 here, I can do this same thing, only notice 15 is not the change, it's the new price. So when I compute this, I am going to get the new percent. In fact, if you plug these numbers in here, you will see that x is equal to 125%. Well, clearly that is not the change. That's this original 100 plus the 25%. So it's 100 plus 25. This 100 represents the original, and this itself, the 25%, is the change. So as you're doing problems like this, I implore you to please make sure that if you've got the new amount over the original, understand that goes with the new percent, and you have to then realize what you're looking at. Whereas if you have change over original, you will get the percent change over 100. So change goes with change, new goes with new. Let's take one where what we don't know is the original. We did this problem in class where Ricardo paid $27 for a membership. This was an 8%, sorry, an 8% increase over last year. How much did it cost last year? I'm going to do it both ways. I'll try to write small. Okay, so if I say, since last year it was the original, we don't know that. If I say 27, that's the new. That means I need that to correspond, we always have 100 here. The new percent here, this is not the change, this is the 100% that is represented by the original price, plus the 8% increase. So if I'm going to have 27 on the top, I need 108 on the top. Okay? And I will be able to get the price of the original. Now I can also say the change. If I were to compute the change, that would be the 27 that it is now minus the original, because that's how we figure out the change. And since it's gone up, the 27 will go in front, over the original is equal to 8 out of 100. And this would be 100 times 27 minus x is equal to 8x. Either way, you're going to find out that x is equal to 25. What you can't do is say 27 over x equals 8 out of 100, because 27 is the new and 8 is the change, so they don't make sense. You must make sure that what you're talking about makes sense and that your proportions match up. You're doing really simple ones, like the very first thing we did. If we've got, I don't know, something that has original price of 30 and a new of 33, and you want to know the percent change, I think it's probably easiest just to compute the change. So change over original equals the percent change out of 100, and clearly since this reduces to 1/10, then x is 10%. 10% of 30 is 3, so the new thing is 33. Those seem to me the easiest the way to do that. Now, what if we say there is, this is actually a problem from your homework. Let's say you have the original price is 32. We don't know the new. And the percent is a decrease. So how would we set up that proportion? Oh, sorry. I'm sorry. It's not a 10% decrease. What we know is that it's a 20% decrease. Okay, so the thing we don't know is the new. We know original has to go on the bottom. We know 100 has to go on the bottom. So if I want to talk about a 20% decrease, this is the change And if I want to figure out the change here, I'd have to say the new, this is, the original is bigger than that. So I'm going to say 32 minus x. So this is the change on top, and this is the percent change. So change lines up with change. And again, I would reduce 20 hundredths to 1/5. It makes it a much easier problem. Why isn't my eraser going? Oh well. So when you solve this problem, you will find out that x is equal to $25.60. These problems don't always come out evenly. All right. This section, some problems about investment. And if you look at the example on page 316, basically the important parts of the problem is that there is a total of $6,000 being invested in two different parts. There's a part that's 6%, and the rest, and then the rest at 11%. And when this person invests it, they earn $460. So I know, if I know how much, if I know the amount, and I multiply it by the interest rate, the percent interest, I can figure out how much I earn. So I don't know how much is getting invested at each part, but I know if I call this part X and it's invested in 6%, which we write as 0.06, then it's going to earn 0.06 or 6/100ths of X. The rest is the total minus the part that got invested at 6 point, and that's at 11%. So that's 11% of 6,000 minus X, and we know it makes a total of 460. So what I know is 0.06x plus 0.11 times 6,000 minus x is equal to $450. What a lot of people believe is that we're more likely to be accurate if we're dealing with whole numbers. Since I need to move this decimal point 2 places over to the right, and this one over 2 places to the right, in order to get rid of decimals, I can accomplish that by doing essentially the fraction destroyer, only with decimals. Since my 100 fits on the right-hand side, I'm going to multiply the whole thing by 100, which leaves this to be 6x plus 11 times 6,000 minus x equals 4, 5, 0, and 2 more zeros. And you can solve that to figure out the rest. So overall, though, with these things, just don't do it without thought. Make sure that your proportions make sense. If you're talking about percent change, then you have to, on your other ratio, be denoting change. If you're talking about the new price, then it has to be with the new percent. Don't mix and match.